So here's a great first example. Solve the following exponential equations. Give both an exact answer and a decimal approximation rounded to 2 decimals. So I'm going to show you the difference between the exact and the decimals. Here's my equation. 3 to the x minus 4 equals 13. Now, if this were back in 7-1, what I would do is I would write 13 as a power of 3. But I don't know what power of 3 I need to make 13. I know, well, first off, 13 is prime, so it's obviously not an integer power of 3. 3 squared is 9, and 3 cubed is 27. So the power is somewhere between a 2 and a 3, right? So we can't rewrite this. So I would say maybe 13 is not an integer power of 3. So we're going to take a log of each side. All right. So there are 2 methods. Method 1 and method 2. I'm getting pretty brave here, thinking that I can fit both of them side by side, but I think I can. I think I can do that. So for the first one, let's pick a log base that matches our problem. So I'm going to take a log of each side, and I've left a little space here so I can pick out the base. Now, since I'm trying to get this variable out of the exponent, this guy's trapped. Woe is him. He is trapped inside of the exponent of the 3. So since he's the power of a 3, like he's in the exponent of 3. 3's the base. That's going to be the base of my logarithm. All right. Now, this might feel a little mysterious, but it's going to be the exact same thing as we did in 7-1. Just looks a little different. Okay. So my power rule says that exponents come down. So I can pull the exponent x minus 4 down to the front. And then I know that log base 3 of 3 is 1. So here's why one would choose to pick a log base 3. All right. So I actually have x minus 4 is log base 3 of 13. So x is log base 3 of 13 plus 4. So this is exact answer. Meaning no approximation. All right. My approximate wants you to round to 2 decimal places. So when I do that, you get 6.33. Okay, so I have so many comments about this, so many comments. First, this is not any different than what we were doing in 7-1. This is exactly the same thing. 7-1, we wrote both sides as, same base to a power, and then we equate the powers. So on this line here, I have x minus 4, which was my exponent, equals log base 3 of 13. This is a power. Remember, logarithms are exponents. This is the power that you raise 3 to get 13, which, if I knew what that was, that's what I would have done right here. I would have just written 3 to the 2.3 or whatever number I needed, right? That's what I would have done. So here I am equating the powers, and then I solve for x. This is exactly what we did in 7.3. I know it feels weird, I know it looks weirder, but it's the exact same thing. So here's my exact expression, log base 3 of 13 plus 4. And then the approximate is 6.33. Now if you put this back in, you get 3 to the 6.33 minus 4, which means that the power you're raising 3 to is like 2.3. Now, that makes sense because 3 squared is 9, 3 cubed is 27, and 13 is a lot closer to 9 than it is to 27. So the power, the overall power, needed to be pretty close to 2. A little bit bigger than 2, but not much bigger than 2, which is what we get. Okay? So lots and lots and lots of stuff is kind of packed into this problem. So I am going to write down my comments. So this is no different. We are still equating powers, but one of them has to be encoded as a log. Because again, I don't know what power to raise 3 to turn it into 13. So the logarithm is that number. All right, the other comment I have is what I call the sanity check. All right, 3 squared is 9. 3 cubed is 27. Oops, you can't see that. There we go. So our exponent has to be a little bigger than 2, which it is. The solution for x is 6.33, which means when you plug it back in and you subtract 4, you have 2.33. So sanity check pass. Okay, so method 2 is you always pick the same base, meaning I don't care that I'm raising 3 to a power, I'm just going to use log base 10 and not worry about it. So log of 3 to the x minus 4 is log of 13. So pull the power down as a factor. Now here's where it's different. In the previous one, I got to say, oh, well, log base 3 of 3 is 1. Bye-bye, one less logarithm. This one I can't do that. So in order to isolate my x, I'm going to have to divide both sides by log of 3. That looks like a B instead of a 13. Let me fix that. There we go. Okay. Now I still get to add 4. All right, so that would be your solution. Log of 13 over log 3 plus 4. So it looks a little bit different than the last one, but it's still the same answer. In fact, this is what I had to plug into my calculator. I didn't show you that because I didn't want to give away what was going to happen in version 2 or method 2, but yeah, I did log of 13 divided by log of 3 plus 4. Why? Because my calculator doesn't have a way to do log base 3 of 13. So what's more important to you? Easy typing in the calculator, in which case you do this, or maybe feeling easier solving, in which case you do this one. Both of them are perfectly fine. It doesn't matter which one you pick. On an exam, I am looking for both an exact and an approximate solution. I don't know on Hawks if they make you enter the exact version or they just take the approximate, but I am going to be looking to see that you have that thing actually written down.